Alright, so I'm going to bench test this speedometer out of I think it's a 91 Camaro RS with the 110 mile an hour speedo cluster. See if I can get a visual representation. Bear with me here, I don't have a mounting provision for this, so I'm kind of stuck with doing this by jumper wire right now, which is a freaking mess, as you can tell. Now, I'm using one of these Eventech DC power supplies. It goes all the way up to 30 volts. Obviously, you don't need that much for a 12 volt system. I put it on 13.7, which is about the voltage that you're running when the alternator is driving the power on the car instead. And then I'm using a Regal oscilloscope. That's what I was using to calibrate the signal before it went in the cluster. And then one of these DDS signal generators. You're going to have to use a pulse width style, what do you call, wave, I suppose. And I'm using a 5 volt signal. Offsetting the voltage a little bit because I was messing with it on the oscilloscope and it was actually showing it going negative and then positive. So I offset the voltage to where it's actually going 0 to 5 instead of like 2.5 plus, minus 2.5, you know what I'm saying, on and off. So you can kind of see the representation with the blue line there would normally be 0 volts, so you can see it would go positive and then negative, positive, negative. We don't want that for a speedometer because you just need a positive pulse on, off, and then that frequency generated drives the speedometer motor. So anyway, these are the settings I'm using. I got 50 degree phase, 50% duty cycle, so it's on and off equally. I'm using a 5 volt amplitude, and then the frequency, I actually already generated this via math, but since it's a 4,000 pulse per mile speedometer, what it's going to look for here is at 1 mile an hour, right here, it's going to look for 1.1 hertz, and then you go all the way down. As you can see, like 20 miles an hour, it's going to look for 22.2. It's kind of funny how it's almost exact with the mile an hour, and then as you can see, you start getting some separation at the bottom where it's 10 mile an hour is looking for around 122 pulses a second, or 122 hertz, because every 1 hertz is 1 pulse a second. So you get 122 of those in a second, and that'll drive your speedometer. Okay, so enough talking. What I'm going to do here is I'm going to turn this knob right here, and you can see the... Sorry, I'm getting a text message on my phone. As you turn this and increase the frequency, like I was saying on the web page, you're going to get a higher readout. So let's see, just for the hell of it, what does 10 hertz give us? And you can see on the oscilloscope here, let me go ahead and scale this back a little bit. So you can see that's the type of wave that I'm looking for. And actually, I probably should have offset the voltage a little more, because you can see I'm actually getting negative 400 millivolts at the lowest, and then the peak voltage I'm getting is 4.67, but that's okay. For testing purposes, all we want to do is verify that the thing works. So anyway, we're at 10 hertz, and let's see where the speedometer's at. Hopefully it's at 10 miles an hour. I'm just testing this here. Okay, so it's actually around 5, which, let me look at the thing again. So, let me see, it could just be the fact that maybe the thing doesn't register until you start getting up there. So what's 20 hertz? Do 20 hertz on here, we should be getting around 19 miles per hour. Now, this is taking into consideration maybe my math isn't perfectly correct. Okay, so at 20 hertz, I'm getting roughly 15 miles an hour. So I think maybe my math is a little off on here, but that's okay. It's a good reference. So we're at 20, and then here, let me go to 30, and then I'll just keep going up by 1 on this, and I'll just keep this here so you can kind of see what's a good angle. Sorry, this is a little difficult. Okay, so now 40, 50, 60, 70, 80, 90, 100, 110. You see we're pretty close there, and then that's 120. And yeah, I mean, maybe there's just some tolerance in the speedometer. Maybe it's a little old. I'm not too sure. I'm kind of chasing my tail back and forth here as far as whether my math is correct or maybe the speedometer needs to be recalibrated. But as you can see, at 120 hertz, we should be at like 109, 108 miles an hour. When you look at this, let me see if I get a better angle. Just stand up here. And you can see we're actually a little bit over 110. And then you can verify by looking at the odometer. You can see that thing's just churning away. Maybe I should just let this keep going until it wraps around back to 0. That's one way to reset that, right? That way I can kind of keep track of how many miles are on my build. So anyway, yeah, that's kind of just a introduction on how I'm experimenting with this. This is literally the first time I put this on video. I hooked it up real quick. I turned the knob. It started registering, so I figured I'd take a video to document it because I'm a little excited. You can see the signal's outputting pretty good over there, and yeah, this thing's just churning away. So I don't know. I'm just kind of documenting this for reference in case anybody else has an old car, old speedometer they want to bench test, and no one else around is available to fix it. So if you have any questions on how I set this up, feel free to comment on the video. I'm just kind of doing this as a guide because I kind of had to pioneer this on my own, and there was some threads I came across online that helped me a little bit with some of the math as far as like tire size and all that, and trying to calculate based on drive shaft revolutions and all that good stuff on what the sensor is going to send to the PCM. But regardless, if you kind of know what the cluster has to input, which is 4,000 pulses per mile in this case, then this is the kind of math you're going to need. And let me zoom in on that equation just in case anybody doesn't know how to calculate it. So you have your hours. It's going to give you your hours when you divide 1 by the mile an hour, and then you convert that to minutes, and then you can subsequently convert it to seconds. You can get how many pulses that's expecting if you want to change the pulses per mile. So anyway, video's long enough. Let me know if you have any questions. Thanks.